So we need to explain the periodic trend as we go across period 3. Now, I hope everybody can see there's not a simple trend like there was for ionic size or ionization energy. I can't say it increases. So this confuses people in exams, because often the question will be, describe the trend. What is the trend? And so, well, there isn't a trend. It goes up and then it goes down again. Well, that's okay. You can say it peaks at group 4 and then decreases. But all they'd be looking for is, can you explain it? And the only way you can explain this is in terms of structure and bonding, which is what you would have looked at last term. So, key thing, what is the type of structure and bonding that's happening in this area? Sodium, magnesium and aluminium. What type of structure must they have? Metallic. Yeah, and we call it a giant metallic structure. So, that's the type of bonding. What does that involve? What is that? That's the attraction between...
all the atoms become ions and they have like free-flowing electrons, so electrostatic.
Yeah, between the ions and the sea of delocalized electrons. So you need to explain that that's held together between the positive nuclei and the delocalized electrons. That's what's holding the structure together. Why does it increase? Why does it go sodium, magnesium, aluminium? What's happening?
So whenever you go up one, there's double the electrons per atom and double the charge per ion, so to speak. It's like Mg loses 2 electrons when it makes an ion, so there's more charge.
Okay, so you've got a higher charge on your ion, and you've got more electrons in your C as well, so you've got a stronger attraction. So as I go across here, the charge on the ion, but really it's the charge on the nucleus, isn't it? The charge on the nucleus is increasing. So the charge on nucleus is increasing. And more electrons in C. Therefore, stronger attraction. What's happening to the size of the ions? Smaller as well. So if I've got small ions, I've got a higher, you heard of the term higher charge density?
Yeah.
You've got, because if you think of me, if I've got a plus charge on me, and then I'm the same but I halve my size, I've got the same size over a much smaller area, so I've got a higher charge density. So the smaller you get, so I've got a higher charge, stronger attraction, and smaller ions. So you've got this, that's why it's getting bigger. Let's try and think about silicon. What type of structure does silicon have? Yeah, giant covalent lattice. So I'm breaking, if I melt that, I'm breaking, when melting, I'm breaking strong covalent bonds, which requires a lot of energy. So giant covalent, all my silicon atoms are connected by giant covalent bonds with each other. They're massive lattice, so I'm breaking lots and lots of strong covalent bonds. So lots of energy required for that one. P4. But why do I see that trend? Why do I see phosphorus, then it goes up to sulfur rather, then down for chlorine, and then down to argon? You have to consider... Yeah, sorry.
It's because the sulfur molecule's larger.
Yeah, cool. So that boy is P4. Sulfur there. Sulfur goes around as S.
8, 2, 16.
Going well, isn't it? It's actually S8. Chlorine is, you should know this one, chlorine is Cl2. And obviously argon is just on its own. So I've got, what's important about van der Waals forces? What do I need to consider for van der Waals forces? I need to consider how many
electrons you've got
and the size overall of my molecule. So sulfur 8 sulfur atoms is obviously going to be bigger and have more electrons than 4 phosphorus atoms, and equally 2 chlorine atoms joined together, and then poor little argon on his own is going to be the weakest out of them all. So that's why it goes low, then up because it's S8, down again for Cl2, and then argon on his own. He has the weakest van der Waals forces between the molecules. Right, so final one, electronegativity. What is electronegativity? Hopefully you looked at this last term. Power of an atom to attract the electrons in a covalent bond. So I've got to have a covalent bond. Some atoms are better at attracting the electrons. So what's the best atom in terms? Who's got the highest electronegativity in the periodic table? Oh, lots of us here. Fluorine, yeah, he is the boy you go to if you want to have a really electronegative atom. So what's happening as I go across a period? The general trend, first of all. What would you state? What is my general trend? Electronegativity increases. Does that surprise anybody? Why?
There's more charge.
Yeah, well, wait a minute. Would you expect a metal to want to attract electrons? What do metals generally do to electrons? Metals lose electrons, don't they? So you're not going to expect sodium to want to attract electrons towards it. Sodium wants to form Na+. He's not going to want to attract more electrons to it. So sodium is the least electron. He really doesn't want it. He is the most reactive metal out of all of these, isn't he? So as I go across my electrons, so chlorine in period 3 is the most electronegative atom. Why is that? What's happening? What's always happening as I go across a period? The number of protons is increasing. Is my shielding changing? No. So I've got more protons, shielding the same. So how is that going to attract the outermost electrons? Attract them all. So it's the same trend as we saw in the atomic side. As it attracts it more, they get pulled towards the nucleus. So chlorine is going to be able to attract them far more than something like sodium. Sodium wants to lose them. And that's why if sodium and chlorine get together, you pretty much have a pure covalent ionic bond, because sodium and chlorine are completely different in terms of electronegativity. Where you start getting covalent bonds is where the electronegativity is pretty much the same, which is over in this direction here. So again, you've got to be able to state the trend.